Hello, and thank you for coming to SIG School Scholars. Today we'll be looking at the laws of exponents. So first, let's say for all real numbers x and all positive integers n, x to the nth power is what this notation means. I mean, how this notation is pronounced is equal to x times x times x, and the number of factors, the number of terms in this multiplication is going to be n terms. So in this notation, x is called the base, and n is called the exponent. And what this notation means is that we're multiplying x by itself an n number of times. So, of course, this means that if we were to take x and raise it to the first power, that would equal x. And if we took x and raise it to the 0th power, we'll have 1. Okay. So with that definition, let's look at a couple of examples. So if we were going to take 2 to the 4th power, we would be this operation would be equivalent to 2 times 2 times 2 times 2. And the result would be 4. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. We're going to take 3 to the 2nd power. This particular exponent, we pronounce it by saying 3 squared, or n squared is how it's pronounced. And n cubed. However, we don't give names to any other powers. So how about 5 to the 4th? Well, we multiply 5 times itself 4 times. 5 times 5 is 25. 25 times 5 will give us 125. And 125 times 5 gives us 625. So now it would be useful to mention a property of exponents. we go. So, this property, let's call it the product of powers property. And this applies for all integers m and n, and for all real numbers x. X to the nth power times x to the nth power is equal to x to the m plus n power. So, if we had x, okay, let's say we have 2 squared times 2 cubed. Well, we would add 2 and 3, and we get b to the 5th. And here's the logic of this. 2 squared, wait, it's 2 times 2. 2 cubed is 2 times 2 times 2. So if we were to multiply these sequences together, we would have to the 5th. Let's go ahead and clear this. So, now we should define a monomial. So a monomial okay, so a monomial is an algebraic expression that is either a constant or a variable is either a constant or a variable or a product of a constant and one or more variables, where a constant is going to be called a coefficient. So the expressions 5a cubed times x and 3x squared y are both monomials, where 5 is the coefficient of the first and 3 is coefficient of the second. So let's simplify monomial. So in order to simplify a monomial, we may have to either add or subtract, divide or multiply. In this case, we're going to multiply these two. So in order to do that, we multiply 5 by negative 30, and our result is negative 150. And we take t, multiply it by t squared, we get t cubed. So we're really multiplying together like terms when we're multiplying together two monomials. Let's take a look at another one. Negative 4a squared b times negative ac squared times 3b squared c squared. So, again, we're going to multiply together all the terms. Negative 4 times the coefficient of the second term is negative 1. So, negative 4 times negative 1 is 4. 4 times 3 is 12. 12, and then here, we're going to multiply together the terms that are like. So we can multiply a squared by a, and we'll get a cubed. We can multiply b and b squared to get b cubed. And we can multiply c squared by c squared to get c to the fourth. Okay. It's not that hard. Now, let's try one more. Let's simplify 8xz times negative 10y times negative 2yz squared. Same thing. 8 times negative 10 times negative 2. 8 times negative 10 is negative 80. Negative 80 times negative 2 is 160. So, x, there's only that one x there. We have z here and z here, and z squared here. We got z cubed. We've got 1y. So, let's go ahead and move on. So, now we're going to look at dividing. Well, no, first we should probably discuss properties of exponents. Some more properties. So we already talked about the what happens when you multiply two terms with exponents. We add their exponents. Now, what happens when you take a power to another power? Well, what happens is that we multiply the exponents together. Well, our first so our first rule, our second rule, our third rule concerns what happens when we raise a product of two real numbers, x and y, to a power n. The result is this. Our final rule concerns powers of negative 1. So, when we multiply a negative number by a negative number, we get a positive number. For example, negative 1 squared will be 1. Negative by negative is negative. However, when we take negative 1 and raise it to the third power, we get that 1, and then multiply by another negative 1. And we get negative 1. And when we multiply by a fourth, we have our negative 1 times negative 1 times our negative 1 times negative 1, and we get 1 again. Based upon these examples, it's reasonable to assume that the product, the exponentiation will lead to positive 1, n is even, and negative 1 when n is odd. We should also discuss one more property related to our first property. Our first property talked about what happens when we multiply two exponents. Our fifth property will, and these are two exponents of the same base. Fifth property concerns what occurs when we divide exponents of the same base. The result is that we subtract. For example, if we divide x to the fourth by x squared, we get x squared. We subtract 4 by 2. Now there's definitely logic in this one, and it'd be easy. It's easily proved statement. If we have that should be a subscript, not a superscript. We divide it by then our result. So when we would simplify this, we would divide out all of these m's, which means that what we'd have left would be an n minus m number of terms, products of terms. Well, terms in the product. We looked at the first one already. The second one, let's say we have a number x to x, and when we raise it to the mth power, we have x times x times x. Oh dear. And we have m terms. Now if we want to take this and raise it to a power n, that would mean taking this sequence and multiplying it by itself n times. Okay, I'm just going to shorten it. And on and on and on until we get to the mth multiplication. Which means what we have done is effectively, well, let's look at this way. If we multiply this by itself twice, basically done the operation x to the nth squared, we would have this many x's. So that would mean that if we took x to the nth power, I mean we multiply by itself n times, we would have x to the m times n x's. We'd be multiplying it that many times. So then we looked at how 4 made sense. Now, I believe all that's left is, what is it, 3? Where we have x, y to the power n is equal to x to the nth, y to the nth. Yeah, that's it. Yeah. Well, we're going to take x, y, and raise it to the nth power. Well, that would obviously mean we're just taking xy times xy, and yada yada yada, xy, and the nth xy. So, that means that we have n x's and n y's in this, which means that we are in fact raising it to that power n times. Raising each one to that power n times and multiplying them. So, there you go. So, there are a couple of other properties that we should mention, I think, before we do some practice. The first is that if we take x over y and raise it to the nth power, the result is x to the nth over y to the nth, and that makes sense because we're just multiplying by itself that many times. So both the numerator and denominator will be raised to that power. And then the other one concerns a negative exponent and then a fractional exponent. And we have x raised to the negative nth power. That is equal to 1 over x to that power. And if we have x to the, let's say, a over b power, that is equivalent to taking the b root of x to the 8th power. Or, let me see. So, for example, if we had 5 and we wanted to raise it to the, let's say, 3/2 power, that would entail taking the square root of 5 cubed. Okay. 5 cubed is 125, and we'd be taking the square root of 125. And that is, let's see, square root of 125 is approximately 11.18. There. So, and also, we mentioned this already, but the, any non-zero number raised to the 0th power will be 1. So, Now let's look at some examples. Okay, let's clear this. Let's look at, we already practiced some, oh, how about this? 5a squared times 4a cubed. So of course we multiply the coefficients, and now, remember the rule that talked about what happens when we multiply two bases with exponent, two bases that are the same. We add their exponents, right? So that should be 28 to the fifth. If we were going to do something similar, 7s to the fourth times t cubed times 4t, we would be multiplying these two constants, 28, s to the fourth, and then t to the fourth, because we would add 3 and 1, the exponents of those two different t's. Now, let's go ahead and do c to the fourth squared. Well, we know that this must be c to the 4 times 2, or c to the 8th. We're going to say we have negative p squared times negative p squared cubed times p. Well, let's go ahead and simplify the first term first. Negative p squared cubed. Well, we have negative p squared times negative p squared times negative p squared. Negative p squared times negative p squared, remember, we add the exponents. It would be p to the fourth. P to the fourth times negative p squared. Again, add exponents. Negative p to the sixth. And then what we're left with is just negative p to the sixth times p, which is simply negative p to the seventh. Let's do a few more. Let's say we have negative xy, negative xy squared to the sixth. We will multiply the exponents, and we'll have negative x to the sixth times y to the 12th. However, remember what happened when we raised negative 1 to an exponent? Well, let's think about it this way. This isn't actually right. It's actually equal to, let's look, negative 1 to the sixth times x to the sixth times y squared to the sixth. Think about it that way. What we have, remember, if it's even, then what we have is just 1. Which means that the real answer is x 6 times y 12. So remember, if it's in parentheses, we multiply everything to that power, and that will include the constants. Now, let's look at something a little bit more involved. Let's simplify 6x squared y to the fifth divided by 2xy squared. Now, what we're going to do, of course, we're going to divide. When we're going to do that is, so we'll divide 6 by 2 and 3. I'm going to divide like terms. How about that? Remember that if we're dividing two exponents, we subtract the top, the exponent that's in the numerator, by the 1 in the denominator. Or, no, subtract the 1 in the denominator from the 1 in the numerator. So what we have is then 3x y cubed. That's our answer. If we have 4c to the 5th over 5d cubed, and we square that, we're gonna square everything here. We'll have 4 squared times c to the 5th squared times 5 squared times d cubed squared. And what we'll have is 16 times c to the 10th divided by 25 times d to the 6th. How about 7x times y to the 5th times z to the 3rd over 14x cubed y squared z to -8th. How about that? This won't be interesting. Now, let's divide 7 by 14. We'll get 1/2. So, in order to write that, we're going to put the 2 on bottom. Now, x minus x cubed is going to be -x squared. I mean, x in the -2nd, because we'll take 1 minus 3. Here, we'll have y cubed. And here, we'll have 3 minus -8. 3 plus 8, which is 11. Z to the 11th. Now, let's use a different color. How about green? We try to write this so that we don't have negative exponents. Now, remember how x to a negative exponent was 1 over x to that exponent. Because of that, we can write this, and this is how we write it correctly. Y cubed times z to the 11th over 2x squared. So a numerical example of that rule would be, how about red this time? Yellow, that's good. 3 to the -2nd will equal 1 over 3 squared, which is equal to 1/9. Okay, now let's look at one last example. Let's use a color slightly less irritating than yellow. Red. Let's say we have 25x cubed y to the 18th z to the 4th x, we'll put x there, x 4th there, 50 x to the 4th, another w to -2nd, so perfect. Now let's simplify it. Now first divide 25 by 50 and we'll have 1/2. So we're going to put a 1 on in the numerator and a 2 in the denominator. We'll put the 2 there. X cubed over x to the 4th. So we'll subtract 4 from 3 and we'll get x to the -1st. Then y to the 18th over y to the 9th. What we'll get is y to the 9th. z to the fourth over z to the fifth, z to the negative first, and w to the negative second over w. A couple interesting ways to look at this. Well, we could do, negative 2 minus 1 and get w to the negative third. We also look at it as w 1 over w squared times w, which is 1 over w cubed, or w to the negative third, because remember, we can write w to the negative second as 1 over w squared. And, you multiply by the w already down there. Anywho, we have w to the negative cubed. Negative third, I mean. Is anything else on the bottom besides 2? Let's see. Okay, now this is going to be equal to, remember, we're going to put the negatives on bottom, y to the ninth divided by 2x z to times w cubed. Okay, so those are the laws of exponents, and that's how we simplify some expressions containing fractions and exponents. Well, thank you for watching the video. If you want us to make a video on a specific topic, just leave a comment either in the comment section below or on our website at sigschooltutors.wordpress.com, and we'll try to fulfill your requests as soon as possible. Thanks.